Hey guys, here is help for week number 2 homework. So I just wanted to start with a little bit of information about linear versus nonlinear. I think it's probably pretty straightforward when you really think about it, but if you're looking at graphs or tables or equations and you're trying to decide if something's linear versus nonlinear, graphs is pretty easy, right? If it's a straight line, it's linear, except vertical. So vertical lines are not considered linear because they don't pass the vertical line test. But basically, anything that's not a straight line plus the vertical lines are considered nonlinear. All right, then after that, you have tables, which we'll definitely look at what this means to have a constant rate of change if you don't understand that. But it basically just means as you check through the x's and the y's and how they're changing, that it's consistent. It creates like a pattern, basically. This would have a non-constant rate of change, and there could be lots of different ways that looks depending on what kind of function it is. And then equations, you may or may not have heard of this. This is called slope intercept form. But any equation that fits this model, y equals mx plus b, is going to create a straight line. And really what you're looking for, and most importantly, is that x has a power of 1. So if it's nonlinear, x will have a power of something other than 1, or sometimes it'll also show like x in the denominator, I've noticed on IXL, but those are ways to tell. So if we go through and look at this first topic here, and IXL topic VMQ. So for this first one, VMQ, I'm really just deciding, is it straight line or no? Which in this case, it's obviously not linear. So this topic is supposed to be pretty easy. This is a straight line, so it's linear. Hopefully you figured out that linear has the word line in it. So this is not linear. This is. So it's pretty easy, right? When you start getting to the equations, that's where you're looking for that setup. Like if I'm looking at the notes that I had written, or I guess I can just write it again, y equals mx plus b. In this case, you're saying g of x, which is really the same idea, just a different way to write y, equals negative 10. So this is the m part, x, and then plus 6. So this is the b part. So it does fit this idea that x has a power of 1 and it's not in the denominator. So this would be linear. This is definitely not, because of that square root over the x. It definitely creates something different. You're really just kind of looking for a normal x. This is h of x equals negative 2. So it's basically saying y is always negative 2. So every point is going to have negative 2 for the y. And so if you think about what that would look like, you're going to end up with that negative 2, a line that goes straight across, which this would just be normally straight. Nonlinear, nonlinear. So I feel like you have enough information now to keep going forward. Doesn't seem like it gets too much more challenging than that. This has an x squared. So since the power is not just a 1, this is nonlinear. This has a power of 1, so it's linear. Obviously not straight. So now I'm up to 80. This has an x in the exponent, not what we talked about, right? It's not a regular old x like over here. So this is nonlinear. This is actually exponential. Okay, so if I move on then to IXL topic F5G, that's really the same thing, right? Except this time now you're looking at tables. So let's flip to a new sheet of paper. F5G. So you're looking for that constant rate of change. So if I'm deciding if a table is linear, I'm looking for a constant rate of change. And so the rate of change I'm looking at is slope. When I say rate of change, I mean slope. which is really the change in y over the change in x. So that's really what I'm comparing for every table. So if I look at what I have here, I'm just really checking what happens as I go down each side. So to get from 9 to 7, I have to subtract 2. And to get from 7 to 5, I have to subtract 2. So this is kind of what I'm talking about, that consistency in the rate. And then if I go up this side, 0 to 1 is +1, and 1 to 2 is +1, which means that if I'm comparing my change in y to my change in x, that's the different sides here. Here I have -2 and +1. And I'm checking to see, is that the same as here, -2 and +1, which obviously it is. So this is linear. It has a constant rate of change. The other way you could check that is you could graph them, right? You could literally take these points and put them on a graph and see if it makes a straight line. But if you're trying to check it mathematically, that's the way to do it. Let's try another one. 3, 4, 5, 10, 7, 4. So I'm going down 3, +1, +1. So I would set up, equal. This is my rate of change, is -3. So 10, 13, 16, 20, 11, 2. So I'm going down 9 and then down 9. And here I'm going up 3, up 3. So again, -9 over 3 means that my rate of change here is -3. So this is constant, so it's linear. All right, -1, 0, 1, 4, 6, 9. That seems a little strange. So 4 to 6 is a +2, but then 6 to 9 is a +3. To get from -1 to 0, I have to add 1. But to get from 0 to 1, I also add 1. So really, since I know this is a pattern, but this is not, I'm going to end up with, so as you can see, 2 over 1 for my first comparison. But then for my second comparison, I have 3 over 1, which that is not true. So this is non-linear. And you could graph these to see that this would create something that was a non-line shape. So I can kind of check these. So 3 to 4 to 5 goes up by 1, and then 0 to 10 to 20. So it's going up by 10 every time. So that definitely makes a pattern, right? That's linear. 10, 11, 12 goes up by 1, and then 8 to 14 is 6, but 14 to 16, that doesn't seem right. Let's write it down just so you can see it. So this goes up by 6, but this one only goes up by 2, whereas these are going up by the same amount. So you end up with 6 over 1 does not equal 2 over 1. Okay, I feel like that's probably enough information then to be able to finish the rest of these. So you're just looking for that consistency when you compare the change in y over the change in x. And if you weren't aware, this symbol, this triangle, in the Greek alphabet is called delta. And it means change in mathematics, the change of, so the change in y over the change in x. All right, moving on. So now we're going to talk about kind of finding slope. And there's obviously a few different ways to do that. If you're looking at a graph, let's see, write down the points. I'm not going to make my graph quite as nice because I don't have graph paper, but I will write down the points that are on here. 40, 80. And then 80, 100, it looks like. All right, so if you look at what's happening here, basically this graph is going from 60 at the starting point on the y-axis to there, here, and then from here to here. So the idea is that it's changing. So it's changing by a certain amount, it's going up by a certain amount and over, or up by a certain amount and over, but that amount that it's changing by is the same each time. And I think in some ways it's easier just to look at the points. So if I have the point 80, 100, and I also have the point 40, 80, I can do exactly what I was doing in the last part of the math, right? Look at it like a table and see how much is it changing by. So 100 to 80 is going down by 20. And then 80 to 40 is going down by 40. So this would be negative 20 over negative 40, which just reduces to 1/2. So that means the rate of change here is 1/2. So every time this graph goes up one box, it goes over 2. This is rise over 1. So up 1 over 2 is really what it's saying. Which we'll practice that a little bit more later. Right now, they're really just focused on you being able to find that. So make sure you read this. It asks for the slope. It says you can write it as a proper fraction, an improper fraction, or an integer. So 1/2. Same idea here. So I'm just going to pull some points off of this time instead of drawing it. So if I look, I have, so I can use the easiest point. This is the point 0.03 at the beginning, right? And then if I keep going, I have a point here at 3.5. And since it's a straight line, I know that that relationship is going to be the same anywhere. So I do have a point here at 6.7, but I don't have to use that one. I can use the 3.5 one if I want to. And it's a little easier number. So that's what I'm going to do. This goes up by 2. This goes up by 3. So that change in y is 2, and the change in x is 3. So my starting point this time isn't very easy to see, but this next point here, 1060 is. And then if I keep going, I have one at 3070. I could also use 50, 80, or 70, 90. So I'm just checking again to see how much. This side goes up by 10. This side goes up by 20. So 10 over 20 is the same as 1/2. So really you're just going through the table, or I'm sorry, through the graph and figuring out how to find points and handling it like we would have with a table. Which brings me to the next topic. Oh, did I not write down what the topic this was? So this was IXL topic E7E. Okay, if we move on to the next topic, which is just finding slope from 2 points. So this is IXL topic MD5. So basically, this is the same as what we were doing, right? 9 and 2, 2 and 5. So I'm going to go up 3 here and down 7. So 3 over negative 7, which is the same as negative 3/7. So that's really all you're doing. I think this is the easiest way to handle this. There is an equation, formula for slope. But I will tell you, I think it's a lot more difficult to explain to students rather than just explaining this. It's the same idea though. If you have a point x sub 1, y sub 1, that means that this point is called point number 1 because we put that 1 there. And let's say you also have x sub 2, y sub 2. So you have the second point. So this is the first point, second point. Really, when you find slope, so that always stands for slope, you do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So really, you're finding the change in the y values over the change in the x values. But again, I think that's harder to explain to begin with. It is the same thing we're doing here, though. We're subtracting to figure out like what the change was here, and we're figuring out the change here, and then putting them in that fraction, which is what we've been saying is the change in y over the change in x. All right, last topic. This one's the one that's a little bit different, kind of preview for next week. So this is IXL topic R5T. So R5T is basically finding the slope when you're in slope-intercept form. So remember I just said that M is slope. Slope is multiplied by, which you can also think of as in front of. It's also in front of the X. So in this problem, it'd be 1/5. So I'm literally just looking for the number that's being multiplied by X. Here, X is here, so it'd be negative 1/4. Number in front of X is 5. Ooh, except, what does it say here? Y-intercept. So that brings me to the next part, which is that this number, this constant, this number by itself, is called the y-intercept. And on a graph, this is where it crosses the y-axis, which we'll talk about graphs later. But just as a preview, we're just going to we'll be able to look at it right now. So if I'm looking for the y-intercept, then at this time, instead of the number in front of X, I'm looking for the number that's by itself, which is 3. So y-intercept this time, number by itself, 1 divided by 5. So slope, so that's the number in front of X this time, so negative 7/9. So really, this is just having you practice being able to tell the difference between the two numbers. Hopefully it seems easy. Y-intercept is the number by itself. Don't forget, though, that since this is minus 3/4, that's really like saying negative 3/4. Slope here would be 5/2. Slope is negative 9/4. Slope is negative 1/3. Y-intercept is a positive 2. Slope, ooh, slope this time is invisible. So what number is invisibly in front of this X? Hopefully you know it's a 1. So this would be a -1. And then y-intercept for this would be 2/5. So I'm already up to 85, and it looks like they're just making the numbers bigger now. So hopefully you feel like you can get past that too. Okay, hopefully that was helpful. Have a good day.